Just look at this. It's such a simple, beautiful scene, right? A single sailboat just gliding across the water. It looks so peaceful, so effortless. But have you ever stopped to think about what's really happening just beneath the surface?
It's a great question because the answer, well, it isn't magic. It's physics. There's this constant, powerful dance of invisible forces going on that makes this whole journey possible. And not just for this boat, but for so much more on our planet. So let's dive in. Today, we're going to explore the incredible unfolding power of water. We're going to see how the science of fluid dynamics literally shapes everything around us, from that one little boat all the way up to our entire world.
Okay, so let's go right back to that boat. To really get why it floats, we need to wrap our heads around two key scientific ideas.
First up, we've got buoyancy. You can kind of think of it as water's secret superpower. It's this upward push that's constantly fighting against gravity. So if an object, like our boat, is less dense than the water it's pushing out of the way, that upward force wins, and it floats.
The second force is something called hydrostatic pressure. Now, this is basically the weight of the water itself, all of it pushing down thanks to gravity. And the deeper you go, the stronger that pressure gets. It's actually the pressure pushing up on the bottom of the boat that creates that buoyant force we were just talking about.
And this is where it gets really interesting, because another huge factor comes into play: salt. The more salt you have in the water, higher salinity, the denser that water gets. And denser water gives you a much stronger buoyant push. That's exactly why it's so famously easy to float in the Dead Sea compared to, say, a freshwater swimming pool.
Okay, so we've gone from a single boat to the very properties of water. Now, let's scale things up a lot, because these exact same principles are what drive the ocean's massive global engine.
Ocean currents aren't just random streams of water. They're basically our planet's circulatory system. This giant global conveyor belt is constantly moving warm water from the equator up to the poles, and then sending cold water back again. It plays this absolutely critical role in regulating Earth's climate, making our planet livable.
So what guides this massive system? Well, it's the very shape of the ocean floor. The continental margins, where the land meets the sea, they act like giant walls steering the currents. And then further out, you have these huge, flat abyssal plains that are like open highways, letting the currents flow like these slow-motion rivers across the bottom of the world. But all this movement of water isn't just about physics and climate. It's directly fueling life in the oceans through this constant, life-giving churn.
And this leads us to a really fascinating puzzle. See, most of the life in the ocean lives up in the sunny top layers, but the essential nutrients they need to survive, they're all locked away down in the cold, dark depths. So how in the world do those nutrients get up to where they're needed most?
Well, the answer is a process called upwelling. It's this incredible thing that happens where wind basically pushes the warm surface water away from a coastline. This allows all that deep, cold water to rise up and take its place. And the crucial part is that deep water is absolutely packed with the nutrients that kickstart ocean life.
And you can see exactly how it works right here. The wind is pushing that top layer aside, creating a kind of vacuum that pulls that nutrient-rich water up from the deep. It's like a fertilizer delivery service for the ocean. It causes these huge blooms of plankton, which then become the foundation for the entire marine food web. This one process is the engine of so much biodiversity.
And this doesn't just happen in the ocean either. A very similar thing called lake turnover happens in freshwater lakes. In the spring and the fall, the temperature changes cause all the water layers to mix together, bringing those vital nutrients from the bottom right up to the surface, fueling life there too.
So, we've seen that water moves heat, and it moves nutrients. But its power doesn't stop there. You give water enough time, and it becomes the planet's master sculptor.
What you're looking at here is erosion in action. It's this relentless process where moving water, like in this river, just wears away at rock and soil, one tiny little particle at a time. Over millions of years, this force that seems so gentle can do something absolutely spectacular, like carve out a canyon this vast. But here's the thing, water doesn't just destroy, it also creates. All of that material it carries away, all that rock and soil, it has to go somewhere, right? Well, when the water slows down, it starts to lose energy, and it has to drop its payload of sand, silt, and soil. We call this building process deposition.
So let's actually see this building process in action. This incredible interplay of taking material away from one place and giving it back somewhere else creates entirely new landscapes. We're even talking about islands born from the water itself.
I mean, think about it for a second. The very same bits of sand and sediment that were scraped off a mountain hundreds of miles away can be carried all the way down a river and then dropped right at the coast. Over time, that slowly builds up and up and up until you have a brand new piece of land, just like the island you see right here.
And this process creates such an incredible variety of features on our planet. We're talking about massive river deltas, sandbars that pop up out of nowhere, peninsulas, those crucial barrier islands that protect our coastlines. Even beautiful island atolls owe their existence to this process.
The scientist Sabrina Miller really sums it up perfectly here. Together, erosion and deposition continuously reshape landscapes. It's not a one-time thing. It's this dynamic, never-ending cycle of carving and creating that is constantly changing the face of our planet.
So, from keeping a simple boat afloat to regulating our entire global climate, from feeding the oceans to building whole landscapes, the power of water is just immense. It has shaped our world from the very beginning. Which really just leaves us with one final and pretty crucial question. Knowing all of this, how will we shape water's future?